complex or compound rational expressions. So what this is basically a fraction or fractions inside a bigger fraction or another fraction. And so forgive me, I will refer to the bigger fraction or the smaller fraction. The smaller fractions are the fractions inside the outer fraction. So as I say them, I don't think that's mathematically proper, but that's what I'm going to say, and hopefully you understand that as we go through this. A rational expression is a fraction where both the numerator and denominator are polynomial expressions. Does not require variables, but polynomials there. When you have a rational expression, you always need to remember there are restrictions. If there are any x's in the denominator or the bottom. For more on these restrictions, watch rational expressions restrictions video because we won't find them in this one. All right, if you are given a rational expression, you always find the restrictions before you simplify. Always. Okay? And then again, for purposes of this video, I'm not going to find the restrictions, but understand they exist. All right? And all the ones that we're going to do here. A complex or compound rational expression is a fraction where the numerator is the rational expression or the denominators are, that's basically saying the top's a fraction or the bottom's a fraction or both of them are. Okay? That's what that says. You have a fraction and the top of your fraction is also a fraction or the bottom of your fraction is also a fraction or they're both fractions. Okay? To simplify a complex fraction, you find the LCD of the fractions contained in the complex fraction. That's what I'm going to call the little fractions, the smaller fractions. Okay? For the purpose of this video, again, I'm going to refer to the fractions as smaller, even though that's not proper. Please forgive me. Multiply both the numerator and denominator by the LCD of the smaller fractions. Okay? Distribute and divide out the common factors in the smaller fractions. And look, I know there's different ways to do this. You can find the LCD of the top and the bottom and then flip the bottom fraction. Also, I'm doing this in a what I think is a quicker fashion than that when you have multiple terms or multiple fractions involved. Factor and divide out common factors in the resulting fraction, and it should no longer be complex or compound. It should no longer be a fraction inside fractions if you follow these steps. Okay? So find the LCD, and then I'm actually going to multiply everything in the numerator and denominator. That's the distribute part. I'm going to kind of combine 2 and 3 and multiply it and show the distribution all at once. I call it show the distribution where I write the LCD times every term. All right, so here, if I look at this, 6 plus 5 over x over 1 minus 7 over x. So here is our little or smaller fraction, these two things here, that are inside the bigger fraction, right? So the 6 and the 1 are not fractions, but the rest of the numerator and denominator is a fraction there. So if I look at this, I have only x as my denominator of my little or smaller fractions. So my LCD that I'm concerned about right now is x. Okay? The LCD that I'm concerned about here is x. And I'm going to mention something as we finish this about restrictions as well. So here, you would look for restrictions, which would involve the little fractions. And then once we get the big fraction simplified, we actually have another layer of restrictions we have to consider. All right? So here, I'm going to multiply everything. So I'm going to say this is going to be 6 times x plus 5 over x times x over 1 times x minus 7 over x times x. Now what I'm really doing is I'm taking x times all this, but if I do that and distribute, then I end up with this over here, right? So I'm basically skipping that step, but I am showing what I'm calling showing my distribution. So instead of writing that step down, I'm saying, you know what? It's going to be multiplied by every term in the top and the bottom, the numerator and denominator. So let's go ahead and go to that step. So then 6x, and then here, let me actually go back. This is going to be 6x for this term, right? And then here, this is a fraction times a whole number. So I need to remind myself, hey, wait a minute, this x is over 1, and if this x is in the top and this one's in the bottom, you can divide them out. So you're left with plus 5, okay? And by the way, I know many people call this cancel, okay? And in the dictionary, it's that. That's because we as math teachers and the math community lied to the world for so long, even Merriam and Webster, that they put it in the dictionary. But it actually doesn't cancel, it divides out. I don't have any book in my office that's less than 30 years old that says cancel. So when I was taught it said cancel. When your teacher was taught they said cancel. That's why your teachers say cancel. That's why sometimes I still say it, even though it really doesn't cancel. It divides out. All right. So then here, this is x, 1x, and then minus, and then this is over 1 again. Those x's divide out, so it's minus 7. I cannot factor either one of these, so guess what? And they're not identical. I'm done. So in addition, so let me write this down, 6x plus 5 over x minus 7. So in addition to looking at these fractions and talking about what makes the denominator 0 for restrictions, you also now have to look at this. So you have an added level of restriction there once you get that simplified, because your simplified answer turns out to be a fraction that may or may not have the same denominator that you started with. And in this case, it doesn't. So you would have another layer of restrictions there because you still have a fraction with a variable in the denominator. So let's look at the next one here. I have a compound fraction again, right? Little fractions inside a bigger fraction. Here, this bigger one, right? And so we're going to say, what is my LCD? Well, it's y. My LCD is y. And if I take y times everything, right, I got to multiply y times this, and this, right? 4 things. So let's come over here and say this is going to be 4 times y minus 7 over y, times y over 2 times y minus 3 over y times y. And again, I'm going to remind myself that these y's are over 1 over here, and so this is going to be 4y minus, that divides out 7, over 2y minus, that divides out 3. And again, there's nothing I can do with either one of these as far as factoring goes, so go ahead and just say that's my final answer. See, I can't take these two things and divide that out. Can't do it because I have other terms there, right? If I have more than one term, I cannot divide something out that is part of a string of terms. So 4y minus 7 over 2y minus 3. So look, I've chosen some really simple ones to start with here, and I don't get too much more complicated than this. I only have a couple more examples. This is definitely just an introduction video to this. I promise you, whoever, your teacher, or if you move on in math and go further and get a degree in math or something, that this can get way, way, way more intense. Okay? This is just an introduction and to remind you, hey, you still have restrictions to start with. Then you get an extra layer of restrictions. That's a new thing. And then how do I solve these things? That's what we're going over here. How do I simplify this into something that doesn't look so awful? All right? Because nobody, I don't care who, if you tell me you like fractions, you're probably lying to me. Okay? So nobody likes fractions, but that's okay. We can learn how to deal with them, right? There's lots of things in life I don't we have to deal with. So this is just one of them, all right? So, but again, learning to solve problems and be efficient, that's what you get from all of these things in math. And that helps you in everything you do in life. Be efficient and solve problems and pay attention to detail. All right, so here I have an x and a y in my smaller fractions, right? So my LCD is going to involve an x and a y, so it's going to look like xy. So now I'm going to multiply xy times everything. So 3 times what? xy minus 4 over x times what? xy over 5 times xy plus 6 over y times xy. Wow, that's a lot to write down, but it's not hard. You're just writing that xy times everything that you had there. All right. So the first part of this is going to be 3xy. All right. And I just realized I didn't change my colors. So this is going to be 3xy. And then here, this is over 1. The x's divide out, so minus 4y. And then here, 5xy. And then here it's over 1, and the y's divide out, and I'm left with plus 6x. So what can I do here? Well, what do I have in common up here? Anything? A y, that's right. So let's factor that y out. Take a y out, and I'm left with 3x minus 4. There's nothing else in common there, so I can't do anything else in the numerator up top. So in the bottom, in the denominator, what do these two terms have in common? Well, they have an x in common, right? So take that x out, and I'm left with 5y plus 6. And again, there's nothing else that comes out. Can anything divide out here? No, it cannot. The x and the y aren't the same. The 3x minus 4, it's 5y, nothing's the same. Look, some of your teachers want you to distribute back out. If that's what they want you to do it. I'm not going to do that. Because this right here, this, you know what this says? This screams to me, hey, guess what? Nothing else divides out, and I know it, and I'm proving it to you that I know it because I'm leaving it factored. Okay? So that's what I require from my students. I want them to leave it factored and prove to me they know nothing else divides out. So there it is. Y times 3x minus 4 over x times 5y plus 6. And then our final one on this one, Looks a little strange. It's got a couple of terms, x plus 3, that are normal, and then we have that old fraction that everybody loves so much, right? Dear old negative 18 over x. So here we have x and x. My LCD of my little fractions is just simply x. So I'm going to multiply x times x plus 3 times x minus 18 over x times x. Right? So I'm taking the x and distributing to all three terms, right? Distributing to all three terms. And doing the same thing down here, taking x and distributing to all three terms. So that's going to be x times x minus 7 times x plus 12 over x times x. Good old x. All right? So then I come back and go, okay, what is x times x? Well, that's going to be what? X squared. And then plus here, this is going to be 3x. And here, this is over 1. So those x's divide out, and I'm left with just good old negative 18. Over x times x here is what? X squared. And then minus 7x comes from this. And then here, the x is over 1. Those x's divide out, plus 12. But wait a minute. Can I factor this? Well, look, these are both list method. 3 terms, no GCF, 1 in the front. So if this factors, let's look at it. It's going to be x and x. And if the one below it factors, it's also going to be x and x. And the top one's going to be the factors of 18. 1 and 18, 2 and 9, 3 and 6. Down here, 1 and 12, 2 and 6, 3 and 4. I want the factors of 18 that subtract to give me 3. Well, 6 and 3, right? 6 and 3 subtract to give me 3. Bigger number gets a plus. 6 is bigger, gets a plus, and the only way to get the negative 18 is for them to be different signs. So it's got to be a minus 3. Down here, factors of 12 that add to give me 7. That's 3 and 4. And here, this says the signs are the same. They're both this one. So they're both what? Both negative. All right? Do you see anything that divides out here? X plus 6 stays. X minus 3 is gone. And I'm left with x plus 6 over x minus 4. And can I divide any of that out? Does the 6 and the 4 divide out? Very good. No, it does not. It cannot. Because 6, it's 2 terms, x plus 6. You can't take that 6 and divide it out with anything else. So that's your final answer, x plus 6 over x minus 4. Now on this one, you would do restrictions right here. You would do the restrictions before you simplify and divide out for the second layer of restrictions here, okay? But it's the same process in the restrictions video. It's just this has an extra layer of them. So I hope that helped you out, introduced you to complex fractions.